are for continuous. So this one, we put -2. It's not close to 2 yet.
Oh.
So this formula in general is for both.
So it's like saying to the left of 2, right?
Sorry?
Is it like saying to the left of 2?
Minus left to the 2. Yes, that's right.
Oh, okay.
Yes.
All right, that makes sense.
Yeah, okay. Okay. Yeah. Any more questions? Any more questions?
Wait, I have one. So, wait, which one is the correct integration? Is it the one with the 3 or without the 3?
No, my answer is right. Just like when I transfer it. Okay, let me go back to the example. Okay, the student point. My integration is right. Okay, just like when I transfer here, I type extra 3. I should remove the 3 here. You see here? This answer is correct. When I transfer to here, I need to transfer 1 minus without. There's no 3. No 3 is okay?
Yeah, no 3. All right, thank you.
You're welcome. Yeah, okay. Okay, now let's go to the, let me see. You cannot see the lecture 4. Okay, let me. Is that this course? I'll make sure that I click the right course. Okay. Can you see this one? We talk about friendship today. Yes or no? Yeah, okay. Okay. Oh, okay, okay, okay. So how do you do your makeup? Oh, okay. You guys can see my.
Yeah, we could see it.
You want to be my friend? Then thank you. Okay, then I'm not so lonely. Okay, so I don't need to go to Facebook every day. Okay. The reason I put binomial and normal together. It's very good example. This is discrete. And then this is continuous. Friendship means when you got difficulty, you're going to help the other. Yes or no? Okay, otherwise there's not friends. Okay, so this one we got formula. We got formula. The formula is, let me see. Yeah, this page. Can you see the formula? Yeah. So let's say x equal to 1. You use a formula. If let's say the questions ask you x less than or equal to 1. X less than or equal to 1. If x less than or equal to 1, that means it's what? X should be what? This is discrete, huh? I got less than or equal 1 friend. That means it's what? 0 or 1. So x equal to 0 plus x equal to 1. Okay, that means maximum 1. Yes. Okay, or that means plus. So that means I need to use a formula how many times? 2 times.
2 times.
So now let's do one more. Okay, life is very simple. Okay, let's say x is less than or equal to 2. I need to do how many times? 3 times? Yes. Yeah. 0 plus 1 plus 2. So you got very beautiful life. Okay. So now let's say x is less than What number that you like? 88. Okay. How many times that you have to do? Okay, you like 42. Okay, I listen to you. Okay, make it 42. X less than or equal to 42. How many times that we have to do? I'm sorry, I changed my question. 43 times? How much time you need? If I put this question for you in the test, how much time that you need? Use the formula 43 times, 20 minutes, 40 seconds, 42 seconds. We use this approach, normal approximations. It helps us to get the answer. Of course, if you use formula 43 times, I think 20 minutes. Okay, I think more than 20 minutes because you need to use a formula 43 times. But as I said, they are good friends. So we use this approach to help us to get this. To help. So first, we need to study this one. After that, then we need to study this one. Then after that, then we get help from the normal to help us to solve these kind of questions. Yeah, if you're using normal, the method we call normal approximations. In probability, we use a lot of time the term of approximations because all the distribution that we have, we cannot get exact distribution like normal. Most of the time, you can see the test questions or the assignment or the textbook or any research paper, they like to use the term approximately normal distribution, approximately binomial. Okay, because it's very hard. In reality, it's very hard to get the exact distribution. That's why they use the term approximations. So, okay, now we use normal approximations. It helps us to get the answer in less than 3 minutes. Yeah. So that's why I put it together. Okay, so one example is for discrete. The other example is normal. And then certain situations, this one can help us to overcome the complexity of the binomial. Yeah. So far, so good. Okay. In order for us to use binomial, and you know that this is discrete. Yeah, okay. So if I say that less than 5 customers, it can be 0, 1, or 2, or 3, or 4. Okay. Can I get negative number? No, we can't get negative number. Okay, the smallest 0, 2, 4. Okay, yeah. So 0 or 1 or 2 or 3 or 4. Yeah. A simple example I can give to you for binomial is you flip a coin. Okay, what do you think about your result? The second time, is that depend on the first time?
No.
You flip the coin, let's say 3 times. Is that the result for the second time depend on the first time? No. Okay.
No.
And this is independent. This is independent. First, it had to be independent. Second, what is the meaning of binomial, like bicycle? Yeah, 2. Okay, so we only got 2 outcomes. Okay, this morning I just finished one engineering statistics. Okay, in engineer, I think even in computer science, okay, it said all the program written in 0 and 1. Is that right? Computer language. In all computer language, there's 0 and 1. Okay, so 0 and 1, we got 2 outcomes. So we can use binomial. Yeah, so only 2 outcomes. We can use the same thing for any system developed by engineer. Okay, either fail or not fail. Okay, failing to use it. Okay, can be used or cannot be used. Okay, so 2 outcomes. And then the situations every time you flip the situation, is flip the coin. So the chances is 50% get tail, 50% get head. Okay, so every time you try it, you try to flip the coin, the situation is the same. So they call an identical try. Okay. So it had to be identical. Okay, you have to use the same coin. If different coin, maybe some of the coin is not fake coin, maybe head is 60%, tail is 40%. Yeah. So it has to be the identical try. Okay. If you want to use not fake coin, it means maybe 60% is head, 0.4 is tail. So if you're using not fake coin, that means every time, n time you have to use unfake coins. You cannot one time you use fake coin, the other time you use unfake coin. No. Are you okay? This one is called an identical try. And then every time you flip the coin, you get, let's say fake coin. Every time you flip the coin, you get 50%. So that means it had to be, the p-value had to be constant, remain constant all the time. Okay, if keep changing, then no. Is that okay? So the p-value had to be constant. Okay, so how to write the model for binomial? Okay, the first day I talk about model. Okay, for binomial model, we write in this form: x as approximately binomial, and then this is n, this is p. Okay, so we need two values. We need n and p. Like for example, I flip the coin 50 times, so your n is 50. So what's the probability of getting? Let's say x is number of hit, so the probability is 0.5. Yeah. Yeah, that's right. Okay, so it does not it's independent. I agree with you. So far, so good? Yeah, okay. The formula is, I put k here, so nk, so this is combinations. And then this is p power to k. And then here, 1 minus p. If you don't to put 1 minus p, you can use the other notations. After p is what? For alphabet A to Z, after p is what? Q. Okay, thank you. So we use Q. Q n minus k. So the exponent you add up together, it had to be equal to n. So k plus n minus k, is it equal to n? Yes. Are you okay with this? Yeah, okay. So the p-value, it had to be between 0 and 1. Okay, I'm sorry. Minimum 0, maximum is 1.
Hey, Professor, can you move the board a little bit to the left so
Sorry?
we can see? Can you move the board a little bit to the left?
To the front or to the back?
To the left. No. Move it more closer because we can't see the full camera. We
You
can't
cannot
see the
see
full
this
board
one?
on the camera.
Maybe it's the light problem. Just give me a second. Okay.
No, Professor, it's not the lights. I have to move it a little
Yeah,
bit.
I meant to move the board a little bit.
Is that better?
Professor, you can
No,
move
move
the
the
board.
board.
closer to
I
the
said
front.
move the board to the right.
Say again?
Move the board a little bit to the right. To the
To the
left, I
left.
meant. To your left.
Maybe
To your
your right
left.
side is my left side.
Toward to
move it.
yourself. Toward
My
to
right side.
yourself,
I got
Professor.
problem to identify left or right. That's why I cannot study physics. This is okay? Yes or no?
Yes.
Okay, I think my marker is not really good. I need to go and get marker, yeah. This is okay? A little bit more? This is okay? I need to respond. You want to be my friend, but you don't want to respond to me. Okay, okay, thank you. Okay. I can tell you before you study this chapter, okay, you know a formula about binomial. You used the formula before. You know what formula? I can tell you, okay. Let's say I said this class, oh yes, I need to let you know because the test, I might wait until Monday because TA only finished marking 2 questions. 2.5 questions. So I still left 1.5. If they finish it end of the week, then I release the marks. If not, they will have to wait until next Monday. Yeah. Okay.
Yeah, that's okay.
Okay. Because my class is very big. Okay. My class is 230 students. If I got 230 friends, then it's very good. Okay. Okay. Let me give you an example. I mentioned to you, you know one of the formula before you study probability cost. Definitely you agree with me after I explain to you. Okay, let's say I said this class, I got 200 students. I make it simple, 200 students, not 230. Okay, let's say 200 students. Probability of getting A is 90%. Okay, I repeat. My class got 200 students. 90% of the students get A. 90% of the students get A in the past. Probability of the student get A is 90%. I got 200 students in this semester. In the past, the probability of getting A for this course is 90%. Okay. The probability of getting A is 90%. So how many students I expect to get A in this semester? How many students I expect to get A for this course? 180? How do you get 180? I got 200 students. In the past, 90% of my students get A. I expect how many students to get A for this course? 180 is what? 200 multiplied by 0.9 is 180. Yes or no? Okay. N is what? Sorry, 200 is N. This is P. Yeah. So I'm talking about expectations. Yeah. So I use E. So we got a formula that is NP. You see, you guys are very smart. Before studying this course, you know the formula. A lot of formula, in fact, we use it in our daily life. We don't realize that that is the formula. Yeah, so this is the formula for expectations for binomial probability distributions. So in fact, you already know a lot of formulas, okay? Any more questions? So this is a formula for expectations, okay? For expectations. Okay, so I think I explained to you those conditions in order for you to use binomial. Okay, now let's go through these questions and we need to find what's the N value, what's P value. Are you okay with this one? Expectations?
Yeah.
Yes. Expectation, that means about future. About future, that's why you multiply by probability. In fact, you already know your probability before you join the class. Okay, go to this example and then let me know what is the N value, what is the P value.
N is the number of trials and P is the probability.
Yes. So what's the value for N?
5.
5. Okay, yeah, good. What's
And
the
then P is 0.4.
0.4. What's the Q?
0.6.
P.
0.6.
Yeah, 0.6. Okay. It's up to you. You want to use Q or 1 minus P is fine. Okay. So now, do you agree the first one and the second one is the same answer? The first one and the second one is the same answer or different answer? First question and the second questions.
I think they're different. They're different.
Difference. Okay. Why? Because the first one asking for what?
For only one.
X equal to 1. Okay. Then the second one asking for what?
At most 1, so 0 or 1.
1. At most 1. So it's what? X equal to 0 plus X equal to 1. So let's use a formula. 5, 1, and then this is what? 0.4 to the 1, and then 0.5 to the 4. Okay, again, 1 plus 4 is equal to 5. Yeah, so then that is your answer, 0.2592. So it can have less than 1. Yeah, less than 1, that means what? I got less than 1 friend.
So you have no friends.
I want to be my friend, so I got less than 1 friend. So that means what? X equal to?
0.
Yes, X equal to 0. Thank you. Yeah. Okay, so are you okay with the calculations? Then you get the answer. So the same thing for this one. We need to use X equal to 1. I can get the answer from here. This one, I need to use a formula again. Yeah, you see here? I transfer this one. Okay. 2 is missing. Okay. Yeah, I put 2 here. Yeah, 2 is missing. 0.2592. Yes, Q is the opposite of the P. Yes. If P yes, then Q no. If P no, then Q is yes. If P is pass and then Q is fail. Yes, the opposite. Yeah, P can be success. If P is success, then Q is fail. If P is fail, then Q is success. Any more questions? No? Okay. Now, let's talk about this question. Can you go through these questions? So now you need to get your P value. The P is not given in the questions. How to get the P value? First, we have to get the N value. Do you use the old notes or new notes? Can you refer to new notes? In fact, I need to put a sentence, but the sentence made you very confused. That's why I remove it. I will explain to you when we finish the whole thing. Do you use the old or the new one? The new one, I remove the sentence. In fact, I should put a sentence. I don't want to put a sentence first because it makes people very confusions. Yeah, okay. The old one, use the new one. Okay, but I still prefer the old one, but I don't want to explain to you. It makes many people confused. Okay, yeah. So far, so good. Okay, So what is your p-value in these questions? Why is 0.6? Just one sentence. Okay, just forget about the O1. Okay, just forget about O1. At the end of this entire chapter, I will explain to you. Yeah. So forget about the O1, use a new one. Everyone want a new thing. Okay. Why is 6/10? Because rate, we got 6, total is 10. Yeah, 6/10, so 0.6. Okay, good. Now, how many balls that you want to get? How many marbles that you want to get? Is that 5? Yes, so it's 5.
Professor, why it's N not B?
Huh?
Why X N not XB? The signal before the bracket.
Oh yeah. Okay, thank you. I always thinking about binomial. Thank you. It should be BIN. Okay, binomial, not N. N is normal. Okay. I'm thinking of teaching you normal approximations. Okay. Thank you. Binomial. Yes. Okay. So now we got N, we got P. Okay. So the questions are determine the probability of getting 2 rate. So getting 2, that means it's what? What should I put here? Should I put more than or equal? Yes, thank you. Okay, exactly, that means 2. Okay, so after that, we got all the informations. So we got the model with the N, with the P, then we have no problem. So it's what? 5, 2, and then 0.6 to 2, and then 0.4 to the what? What should I put here? Is that 3? Yeah, okay. So then you get the answer. Did I show you the diagram? I'm not sure. No. Oh yeah, I show you all the calculations. Okay, here, I show you those calculations first before we talk about the last statement. Okay. If you look at this number, what do you think? Is that the number? There's only one biggest value only. Is that we only got one biggest value among those? This is the biggest numbers among all the probability value. Yes or no? We only got one biggest value. Okay, so 1, that means this is the most popular one. Okay, most popular one we call mode. So binomial distribution is unimode model. That means they only have one model. Okay, one mode value. That means the highest peak, they only got 1. That means it's go up and then go down. Okay, it can be like this. Okay, but they won't go up and go down and up again. No. Okay, yeah. So that means they only got one highest peak. You can do all the calculations. You can try and change it to 6. You can change to 6. And then you're going to get something like going up and go down. Okay, sometimes. So the highest peak, we only can get 1. That's why they call uni 1. Okay, unimodel. Okay, I think I show you here. Yeah, you see here? They only got the highest bar, only 1 only. This side is not equal, left side is not equal to right side. Okay, so this one we cannot consider as normal. And again, this is discrete. So this is by Binomial is something like up and then going down. Okay, so they only got one highest peak. Okay, I skip this one first, then I come back. Yeah, okay. Okay, now go to this example. Why the p-value is, of course, they got 6 drinkers, so n equal to 6. But why the p-value is 0.5? Anyone can respond?
Is it because there's only 2 types of Coke and it's only either Cola S or Cola F?
Oh, yes, because they say no tendency. No tendency, that means what? They are okay. Both are okay. So that means they like both. Okay, they like both. So if they like both, that means what? Each one is what? 50%. Yeah, that's why here is 0.5. Okay, I think my question does not, I forgot to put a question. The question asks, what exactly 3 before S? Okay, yeah. Of course, in reality, we don't have Cola S and Cola F. Okay, if I put diet and regular one, definitely you know the difference. Okay, that's why I changed to S and F. Because diet and not diet one is very easy to differentiate. Yeah. So are you okay? Why is 0.5? Because the question says no tendency, so they are okay for both. That's why each one is 0.5. And I should put down questions. Maybe you just help me to put down. Calculate x equal to 3. Okay? So the question asks you x equal to 3, then you get this number. So why is x equal to 3? Because I do not type the questions. Okay. I do not type the questions. Maybe at the beginning you can type here. Find x equal to 3. What does no tendency? Oh, tendency, that means towards. That means you are more prefer something. But no tendency, that means you have no special preference. Both are okay. So both are okay. That means 50-50. Yeah. Not prefer one or the other. Yes, that's right. This is okay. Why I put x equal to 3? Because I need to type the question. I forgot to type the questions. I just thinking about Coke. So far, so good. You want at the beginning just help me to type down, write down x equal to 3. Then you know that the question wants you to find x equal to 3. Okay, now they got a question here. The probability that at least 2. So in math, if we got simple method, then we use simple method to do it. Okay, so x, the question asks you to find what? At least 2. Okay, so do you want to do this way? X equal to 2 plus x equal to 3 plus x equal to 4 plus x equal to 5 plus x equal to 6. Do you want to do this way? Yes or no? No, it's a lot of work to do. Formula you need to use how many times? 1, 2, 3, 4, 5. Okay, so we know that, like just now I said that 90% of the students get A. So how many percent not getting A is the complement. Okay, so we can use the complement method. So it's what? 1 minus what? No, we don't want to use this one because we need to use a formula 5 times. Okay, so the complement, we should do what? 1 minus what?
1 minus p.
Everything. 1, that means 0 to what? 6. Probability of 1, that means x equal to 0. 1, 2, 3, 4, 5, 6. Yes? Okay, so now we don't want to use this way because it consumes a lot of time. So we do the complement, the opposite. So 1 minus, you want 2, 3, 4, 5, 6. So you take away 1, take away this one, take away this one. So 1 minus x equal to 0, minus x equal to 1. Everyone agree? So we use complement. Yeah, you see here, I use complement, so I get answer faster. I only have to do twice only. Okay. Is that complement is good method? We should use complement all the time. Yes or no? Should we use complement all the time? No. Okay. The reason that we use complement, it helps us to get answer easily. Okay. Subject to the question, yes. So the last one. Of course, you want to use complement, you still can get the answer. Okay, x less than or equal to 1. That means what? X equal to 0 plus x equal to 1. Let's say you use complement. It should be what? 1 minus what? Let's say you want to use complement. Okay, you love math so much. You like to spend 24 hours to do math questions. So what should I put here? If I want to use complement, 1 minus what? I need to respond. If this question, I insist to use complement, so what should I put here? 2, 3, 4, 5, 6. Yes. Minus x equal to 2, minus x equal to 3, minus x equal to 4, minus x equal to 5, minus x equal to 6. You can get the answer. Complement also, the regular also. Of course, you don't use complement. Okay, yeah. Yeah. So far, so good? Yeah, it's not subject to the question. It's not complement. It's useful for all the time. Depend on the question. Like this one, don't use complement. Okay, use a regular one. So far, so good? Okay. Now, okay. No need to get the final answer. I just want you to write down the step for me. At least you write down the model and the x value should be equal, should be less than, or should be more than. Yeah. Can you help me to do A, B, C, D? After the class, maybe you can enter the calculator, see whether you get the same answer. Now, I want you to set out the model binomial model. Okay, set up the binomial model, and then every questions A, B, C, D, just help me to write down the first step. That's enough. Yeah. And then tell me which one you think that we should use complement. First, I want you to set up binomial model. That means you have to find out what's N, what's P, and then after that, A, B, C, D, you set up something like this one, that's enough. And then you tell me which one you want to use complement method to solve it. Just want to make sure that you're clear with my questions. Huh? Are you clear with my questions? Yeah, okay. Complement for C, almost. Which one? I think only one question you need to use complement. The rest, use the regular one, is easier. B, you want to use complement? Almost. A, B, C, D, E, F. I don't have F here. Okay, I only got A, B, C, D. Okay, let's do it together. Okay. Okay, so according to your survey, 86% of Canadians have no saving. So your X refer to no saving. Yes or no? Yeah. Okay. So X, the model is what? M is what? 8. And then your P is 0.86. Yeah. Okay. So A, X equal to what? 7. So just use a formula one time, that is enough. Is okay? Why we use 1 minus? No, A, they ask you exactly 7. Exactly 7 young professionals in this sample have no saving. Why you put 1 minus X equal to 1? Okay, is that okay? Because the question asks you exactly 7, so X equal to 7. So right away, we can use the formula. Everyone okay? Yeah, I want to make sure the student can understand my explanation. The student, are you okay with my explanation? Because this one right away, we can use a formula. Okay, yeah, okay. So B, how about B? At least 7. At least 7 is what? X is more than or equal to 7. Okay, so this one, I think we use traditional way. X equal to 7. What should I do here? Plus X equal to 8. Should I continue? Should I put X equal to 9? No, because I only got AP pony. Yeah. Okay. C and most 7. And most 7, that means maximum 7. Yeah. Yes. So at most 7, that means if you use the traditional way, X equal to 0 plus X equal to 1 until what? X equal to 7. There are many work to do. Yes or no? Yeah. So now we do 1 minus X equal to 8. Yes or no? Is it minus 7 or 8 or just minus 8? Yeah, okay. Which one is correct? This one or this one? 1 minus X equal to 7 minus X equal to 8. Which one? Number 1 or number 2? Yes. Yes. Why number 1? Because we want 0 to 7. 1, that means everything from 0 to 8. So 0 to 8 minus 8. So left what? 0 to 7. So that's why it's number 1. Yeah. D is up to you. There's another way to do it. We set up another model. Can I erase this one? Can I erase this one? Okay. D, we can set up the other model. Now, another model, we don't use X anymore. Maybe we use Y. Y is what? the question say about saving. Yeah, okay, so y binomial 8. How many percent of people got saving? Now, can I put 0.86 here? No, 0.14. Okay. Yeah, I don't want to mix up. X is referred no saving, Y refers saving. Okay, so at least 2. So X greater or equal to 2. So now we have to do what? X equal to 2 plus X equal to 3 plus until what? X equal to 8. Yes or no? So now, I think it's too much work to do. Okay, so 1 minus what? X equal to 1. Everyone agree or no? Yes or no? You always want to be number 1. Do you think that this one equal to this one? Yes or no? No. No. Why? Because everything starts from what? 0 to 8. So what happened to the 0? So we need to minus X equal to 0. Yes. Yeah. Don't forget about 0, okay? 0 is part of the chance. So we have to minus 1, we have to minus 0. Minus, not plus, minus. So far, so good? Oh, now it's 12:20. Can we reverse our time to 11:20? Then I can continue the class.
Let's go back to 11:30.
The calculation is different, right? Yes, but your answer is right. At the end, your answer is right. This answer and this answer, you get the same answer. Yeah, so now in this y, this one become p. Q is 0.86 because my definition y is saving. The x is no saving. I love this student who type everything. You're very good in typing. Yeah, thank you. Yeah, you want to use NCR or this one still the same? Yeah. You can take pictures. This student is so nice. I wish I can see you again next semester. Okay, for the other course.
Are you teaching next semester?
Sorry?
Are you teaching next semester?
Next semester, I'm not sure. I need to take care of my mom, yeah. Because my mom is in palliative care, yeah. She's 91 years old. Give me 1 more minute. I need to talk more, okay? Otherwise, I need to wait another 48 hours to talk to you guys. Okay, give me 2 minutes before we do the conclusions? In every functions, in every distribution, they got functions. Is that right? Okay, so this is continuous. I promise to show you my thesis. I use a lot of function. I do a lot of integration. I go and find out, okay, and show you on Friday. Okay. Are you able to do integration for this one? Are you able to do integration for these functions?
I think yes.
I don't think so complicated because our variable is x. Look, got mu, got standard deviations. Okay, so I don't think so it's hard to do it because this is exponential function. Yeah, I think we can do it. Okay.
And I think we would just treat mu and sigma as constants, so it won't matter much.
And then this pi is also constant. Yeah. So we only had to do it respect to the x. Yeah. Okay. So, but this course will. I'm not going to ask you to do the integration of all the functions. Some functions very complicated. You know gamma function? Yes. You know gamma is
It's a factorial, basically.
okay. If you are interested in gamma functions, my master thesis is regarding a portfolio, a universal portfolio. The guy who invented this portfolio, investment portfolio, you know the mini portfolio strategy, okay? This one, I use a lot of gamma functions. This guy who invented, he was a retired professor in Stanford University. His universal portfolio for stock market investment is very useful. It's very, you can enter into the Google and then check universal portfolio. This guy used a lot of gamma functions. Yeah, okay. Let me finish about normal distributions. So here we got two parameters, mu and variance or standard deviations. Mu, but here we always put variance, okay? So if you want to we need two parameters. They are mu and variance, or mu and standard deviations. Yeah, okay. These two parameters are very useful for normal distributions. Okay, are very useful for normal distributions. It reminds me I need to go for the other class. Okay, before I end the class, I want you to do a summary for me. Anyone can do a summary for me?
We learned about binomial distributions, how they're independent trials.
Yes, we learned about binomial distributions, and then we had to follow the conditions. The 4 conditions are very important. If you don't follow they do not fulfill these 4 conditions, we cannot use a formula. And some questions, we can use a shortcut to do it. That is called complement, okay?
One more thing,
When do we use binomial? If we got 2 outcomes. If we got 2 outcomes, then yes, we can use binomial, and then we also have to follow the other 3 conditions. We need to fulfill the 4 conditions, then we can use binomial.
And then we have normal distribution as well, which is the one we have the formula, and then we also have the phi formula.
Normal distributions?
Yeah.
Okay, we talk about it on Friday. Okay, we talk about it on Friday. So now make sure everyone clear with binomial distribution. Okay. Are you okay with binomial distribution, especially when you solve the questions? Sometimes we need complement, then we need to use complement method. Otherwise, it takes a lot of time to do it.
I mean, yeah, with two outcomes, yes.
Yes, we need to have 2 outcomes. 2 outcomes.
With 3 outcomes, can we do it with another distribution? If there was 3
outcomes, we can simplify. Maybe the other 2 we combine together. Let's say the marbles, we got red, green, and blue.
Yeah.
Red, green, and blue. Okay, maybe we can combine. If the question asking about blue color, these 2 we combine together become not blue. They become 2 outcomes. Yes, only 4 conditions. Yes. Okay, so I'll let you go for your lunch. Yeah. Okay, so I see you on Friday. Yeah. Okay.